Welcome back. It's Mrs. Allen again, and today we're going to continue our conversation about the states of matter, often called the phases of matter, and talk about how those can possibly change sometimes. So, the title of this one is Changing the State or Phase of Matter. And here you see a diagram of those molecules that we talked about yesterday. So, in a solid, they're all compact together. In a liquid, they are looser, they're not as attracted to each other. They have more kinetic energy. Here in the solid, remember, they're still moving. They're just vibrating closely together. They're moving a lot more freely here in a liquid. And then when they get to a gas phase, they can just move wherever they have space. And that usually happens with the temperature rising. Like we said, the molecular motion is increasing as we go from left to right. And the molecular interaction is decreasing because they're farther apart from each other when they're a gas. Here we are to review the three states of matter: solid, liquid, and gas. And here they are again in their molecular phase. With here, they're tightly connected, strong forces. Here we have weaker forces connecting together. And then while they're in a gas, there's no forces that are connecting them together. And then we asked the question yesterday, can a substance change their phase? Well, hopefully you thought about that a little bit and you realize that yes, in fact, you interact with one of these substances probably on a daily basis in all of their phases, and that would be water. So we're going to watch this 2-minute video to see how adding energy can cause a phase change from a solid to a liquid to a gas in water.
Water is one of those rare substances that can be easily observed in all three states of matter: solid, liquid, and gas. It is in its solid form at temperatures lower than 0 degrees Celsius, liquid when the temperature becomes positive, and gaseous above 100 degrees Celsius. We need to look for explanations at the molecular level. At low temperatures, strong bonds join the molecules to one another to form a compact and geometric network. This is a crystal. When the temperature rises and attains a level of 0 degrees Celsius, the bonds holding the molecules together become weaker. We observe a change of state. As long as any ice remains, the temperature of the water remains at 0 degrees. We therefore do not know in which state we will find water at 0 degrees. It could be completely solid, or completely liquid, or more often, a mixture of liquid water and ice. Once all of the ice has melted, the temperature of the water becomes positive. The heated water stores energy, and the temperature continues to rise. The water molecules become more and more agitated and move apart until they are no longer bonded to one another at all. The water is in the process of vaporizing. Note that water vapor, like many gases, is invisible. The water reaches 100 degrees Celsius and will remain at that temperature for as long as any liquid water remains. The molecules of a gas move about freely and cover great distances before colliding with one another or with the walls of the container. This is why a gas does not have a fixed volume. It occupies all available space. It is only after the complete vaporization of the liquid water that the temperature can again begin to mount.
Okay, so there we see that water goes from solid to liquid to gas, and we interact with that all the time. But what about other substances? Can other substances also go from a solid to a liquid to a gas? Well, let's look here at this periodic table. And we're going to see here that hopefully you can find your element that you did your project on. But what I'm interested in this particular time is the properties of these elements. And I'm going to go ahead and increase my temperature to room temperature over here, which is about 298 in kelvins. And you can see here that that's about 77 Fahrenheit. So maybe a little bit lower, maybe like 295 would be 71. So that's about room temperature. And here you can see all the elements have now changed colors to either black, blue, or red. And what those colors mean is that something is a solid, a liquid, or a gas. So I'm going to take it off a wide so you can see more of it. And I'm going to increase this temperature. So let's think about gold. A lot of you did your element project on gold. So that's right here, number 79. And at room temperature, we would all know and expect that gold is a solid. But if I keep increasing this temperature and watch as the other ones around it change, oh, right there, you see where the gold element changed from black to blue, and that means it became liquid. So maybe you've seen liquid gold, but if you keep increasing, then you're going to see that at some point, oh, right there, now it changed from blue to red. So at some point, gold can also become a gas. And that's pretty interesting to hear. Nobody thinks about having gold as a gas. And as I go higher and higher and higher, almost all of these elements are eventually going to become a gas. Some of them are gray, and it just means unknown. They haven't been able to test those elements at those high degrees. And then again, if you go down really, really, really cold, you would expect that almost everything would become a solid, except, if you notice, helium. It does not become a solid even at 0 degrees Kelvin. So what that just tells us is that all substances have a point where they change phases. And here's an example of that cycle. So we have solid changing from liquid, or liquid changing from solid. That's the most common, freezing and melting. We are very aware of that and do that in our daily lives. We also have evaporation and condensation. So condensation you might see on grass or leaves in the morning, or on a cold glass that you put into a room temperature room, and then the water vapor will start collecting from the air onto that surface. So the water vapor in the air can collect on the grass, it can collect on the glass, and that's condensation. Vaporization, you've also seen, is when a liquid turns into a gas. So that can happen from boiling, like when you boil water and you see the steam coming out, and it can also happen just from evaporating. So if you put a shallow dish of water out and leave it in the sun, you're going to come back and see that that water is gone. It didn't boil, but it did evaporate and it became vaporized into gas. But what about here? From a solid to a gas, or from a gas to a solid, those are not as common. That's not as common of a process. So I'm going to explain that one next. So first, I just want you to watch these really short videos about sublimation and deposition.
Hey, what's up? It's Mr. J with Sci and the Fly. Today, we're talking about dry ice. So what is dry ice? Dry ice is simply carbon dioxide that's been frozen. We find carbon dioxide everywhere. We find it in the atmosphere. We find it when we exhale, when we breathe. We find it in our soft drinks. That's what adds the carbonation. Carbon dioxide's everywhere. We can do a lot of really fun stuff with it when it's frozen. And I say frozen, I mean really frozen. This is negative 110 degrees Fahrenheit, or negative 78.5 degrees Celsius. This is very cold, which is why I'm wearing my glove today. It's very dangerous if you touch it to your skin. One of the really fun things to do with dry ice, and a lot of people do it during Halloween time, is they simply throw it in some water and kind of make it that foggy, mist, scary look. What I have here is a very large beaker, 3,500 milliliter beaker, and I've warmed up the water. And what I'm going to do is I'm going to place this dry ice into the water. And what I would like for you to do is just observe what's happening. Right now you can see a little bit of this fog coming off of the dry ice because of the room temperature versus the negative 110 degrees below zero temperature of this ice. When I do this, I'm going to place it in there, and immediately what you're going to see is you're going to see a very quick reaction. What's happening here is called sublimation. We have solids, liquids, and gases are our three main states of matter. The solid, which has molecules that are tightly pressed in together, vibrating, which was what the molecules look like in that dry ice. When I place them into the liquid, the molecules in the liquid are slightly sliding past one another. And then immediately you get gas, which is this right here, which is perfectly fine to touch and actually feels rather warm. Gas molecules are spread apart and they're moving quickly. Sublimation is the process of which solids turn directly into a gas. They completely miss the liquid wet state, which is why we call it a dry ice.
So we had that information on dry ice, turning from a solid to a gas and not melting in between. And then here's another example of another element that does the same thing, and this is iodine, and it's another short one.
In this video, we're going to look at the sublimation of iodine. So when we add solid iodine to hot sand, we have a hot plate underneath there, you can see right away we start getting a purple gas. That is iodine gas. And with sublimation, we're going directly from a solid to a gas without passing through a liquid phase. So you can see here that after a while, when that gets even hotter, we get a lot more of that purple iodine gas, which is escaping through the top of the beaker. So we can actually capture that gas. Right now it's escaping through the top of the beaker, but we can put a piece of glass on there, a watch glass, with ice on it. And that's really cold, and that's going to change the iodine gas back to a solid. It won't go through a liquid phase. It'll go directly from the gas to a solid, and that will stick on the bottom of the glass. Here's what it looks like from the top. You can see the ice, the watch glass, and then you can start to see that the crystals of iodine are forming underneath. So after a while, the crystals will have formed on the bottom of that glass, and you can see them here sort of dangling down from the watch glass. If we were to take that watch glass off and look at the crystals, they'd look something like this. So here in this video, I'm actually taking the watch glass off. You can see the iodine gas escaping. Then you can see those iodine crystals there.
So those are the two examples of sublimation, which means going from a solid straight to a gas, and then deposition, which means the opposite, going from a gas straight to a solid without ever going through a liquid phase. This doesn't happen very often with very many substances. So these are two that are pretty cool that you can see it happening. Okay, you're going to need your notebook out and you're going to draw this diagram on page C11 and you should label it phase changes. You're going to draw this diagram showing how matter can change from one phase to another. So just make sure that you include all of these parts, gas, liquid, solid, and you label how that happens. So deposition, sublimation, condensation, vaporization, freezing, and melting. And just make sure you know that that happens at the same temperature. So whatever the freezing point is of a liquid, that's also the melting point. They talked about that in the one about water. So here's what your page C11 should look like when you are done drawing and labeling. And then we're going to get on to today's assignment. So today's assignment, number one, is to draw the phase change diagram on C11. And then number two is going to be to complete today's doc. And that should be attached in Google Classroom. And I'm just going to show you a quick picture of it. Okay, so you have your three states of ordinary matter. You're going to make sure that you've watched the video and look through your notes before you try to answer these questions. So the state or the phase, like solid, liquid, gas, you're going to give examples. You're going to give common characteristics of them. And then at the bottom, you have two analysis questions. What's the biggest difference between the states of matter at the molecular level? So what are the molecules doing that's different between a solid, a liquid, and a gas? And then the second analysis question is asking you, pick one of the phase changes you learned about today and explain it in your own words. Okay, I will see you again tomorrow. Thanks for joining in and have a great rest of your day.